Imagine standing at a crossroads between two worlds. One is dry, cold, and barren, but close enough that we might one day walk on its surface. The other is a tantalizing mystery, possibly lush, Earth-like, and orbiting a distant star in the habitable zone. One is Mars. The other is Kepler-452b. One represents a reachable future, the other an unreachable ideal. But which one truly offers humanity its best chance of survival beyond Earth? In this video, we'll compare every known and theorized aspect of Mars and Kepler-452b: location, atmosphere, habitability, resources, technology, and the human cost of getting there. So buckle up for a deep dive into what could be humanity's next home. Mars is practically in our cosmic backyard. It's the fourth planet from the Sun, averaging about 225 million kilometers from Earth. With current propulsion technology, a one-way trip to Mars takes about 6 to 9 months. Kepler-452b, however, lies in the constellation Cygnus and is over 1,400 light-years away. To put that into perspective, traveling at the speed of NASA's fastest spacecraft, New Horizons, it would take over 25 million years to reach Kepler-452b. Even at the speed of light, it would take more than a millennium. So while Mars is within technological reach, Kepler-452b exists far beyond our current ability to explore in person. Any mission to Kepler-452b would require breakthroughs in propulsion, life support, and perhaps even human biology. Mars has an extremely thin atmosphere, mostly carbon dioxide, 95%, with traces of nitrogen and argon. The surface pressure is less than 1% of Earth's, which means you couldn't survive without a pressure suit. There is virtually no oxygen, and the planet lacks a magnetic field to protect against solar radiation. Dust storms on Mars can engulf the entire planet and last for weeks. We don't yet know the atmospheric composition of Kepler-452b, but based on its position in the habitable zone, it's possible that it has a thicker, more stable atmosphere. If it does have a magnetic field and water vapor, clouds might form and precipitation could occur, creating Earth-like weather patterns. But again, this is speculation. Mars is cold. Its average surface temperature is minus 60 degrees Celsius, minus 80 degrees Fahrenheit, though it can range from 20 degrees Celsius, 68 degrees Fahrenheit, during the day at the equator to minus 125 degrees Celsius, minus 195 degrees Fahrenheit at the poles. There's evidence of frozen water at the poles and underground, but liquid water is extremely rare. Kepler-452b orbits a star very similar to our Sun, but that star is about 1.5 billion years older. This could mean that Kepler-452b is experiencing a runaway greenhouse effect, similar to Venus, as its host star grows hotter. Alternatively, it might be in a late stage of habitability, slowly transitioning from an Earth-like world to something less hospitable. The climate could be temperate and Earth-like, or it could be a superheated wasteland. Without direct observations, we simply don't know. Mars has been thoroughly mapped by orbiters, landers, and rovers. It features the tallest volcano in the solar system, Olympus Mons, a massive canyon system, Valle Marineris, and ancient riverbeds that hint at a wetter past. Its surface is dry, rocky, and covered in iron oxide dust that gives the planet its red color. Kepler-452b's surface is completely unknown. Based on its size and density estimates, it may have a rocky surface, perhaps with active tectonics, mountains, or even oceans. Some speculate it might have vegetation if conditions are right. But for now, all visuals of Kepler-452b are purely artistic. Mars shows tantalizing signs that life may once have existed. NASA has discovered organic molecules, seasonal methane spikes, and features that resemble dried-up lake beds. While no definitive evidence of life has been found, the conditions may have been right billions of years ago. Kepler-452b, if it has liquid water and a stable atmosphere, could currently support life. In fact, because of its Earth-like qualities, it's one of the best exoplanet candidates in the search for alien life. But again, until we develop better telescopes or interstellar probes, we won't know if life exists there. Mars has already been targeted for colonization. SpaceX, NASA, and other agencies have proposed plans for building habitats, growing food, and generating oxygen from local resources. Challenges include low gravity, high radiation, and extreme cold. But with the right technology, like underground shelters, radiation shielding, and hydroponics, Mars could be made livable. Kepler-452b, in contrast, is not even remotely colonizable with current tech. We can't land, can't test, can't sample. Even if we could travel there, adapting to the higher gravity and unknown biosphere would be an unprecedented challenge. In essence, Mars is hard. To reach Mars, we need reliable rockets, radiation shielding, and life support systems. These are all under development. Starship by SpaceX aims to carry humans to Mars within the next decade. NASA's Artemis program and its planned missions to the Moon also paved the way for Mars exploration. Reaching Kepler-452b would require propulsion systems that don't exist yet, such as nuclear fusion drives, antimatter engines, or theoretical warp drives. Cryogenic sleep, multi-generational ships, or artificial intelligence-operated missions would be required for such a long journey. Even sending a robotic probe there would take tens of thousands of years. Mars offers potential for long-term survival, albeit with difficulties. Over centuries, we might terraform sections of the planet, introduce genetically modified plants, and even build partially self-sustaining cities. It would be a human frontier reshaped by science and resilience. Kepler-452b could be a paradise, but we have no way of knowing. Even if it's habitable, we might not survive the journey. And if we did, the planet might be more alien than welcoming. The gravity, atmosphere, microbial life, and environment could be hazardous in unknown ways. Mars is a project. Kepler-452b is a mystery. Mars missions are estimated in the tens of billions of dollars. While expensive, the costs are within the range of national space agencies and private spaceflight companies. A mission to Kepler-452b would cost orders of magnitude more and involve risks we can't even calculate. It would require a global effort, a planetary commitment, and technological revolutions. But the reward? A second Earth. So, which is humanity's real second home? Mars is close, reachable, and scientifically fascinating. It represents our first small step into becoming an interplanetary species. Colonizing Mars could teach us how to live on other worlds, protect Earth, and inspire generations. Kepler-452b is a symbol of what lies beyond. It challenges our imagination, our ambitions, and our limits. Though unreachable today, it might be humanity's final destination, a place to settle after we've mastered the stars. For now, Mars is the future we can build. Kepler-452b is the future we can only dream of. But sometimes dreams are what push us forward. If you enjoyed this exploration of Mars and Kepler-452b, don't forget to like, subscribe, and hit the notification bell. Which planet do you think is the better candidate for humanity's next home? Leave a comment below and join the cosmic conversation. Until next